Hello everyone, welcome to my YouTube channel. I'm Varsha from Sri Venkateswara College of Engineering, currently studying in second year Electronics and Communication Engineering department. Today we'll be solving numerical problems of the subject controls and circuits. So first we'll be solving the numericals based on Thevenin's theorem and superposition theorem. First, we'll be solving a problem on superposition theorem. So the question we have here is for a network shown in figure below, apply superposition theorem and find the current I. We have a resistor of 8 ohms and a current source of 5 amperes and an inductor of J10 ohms and capacitor of minus J2 and minus J2 and a resistor of 4 amps and a voltage source of minus 20 volts. The solution for the above problem is we need to open a 5 amperes of current source and retain the voltage source. So from the looking at the circuit diagram, we'll see the 5A current source here is being made is open, and we'll get the resulting circuit diagram will be of RLC network, that is R of 8 ohms and L of J10, and capacitor will be minus J2. This will be in RLC network, and minus J2, other minus J2 will be outside the network along with 4 ohms of resistor. Now we need to calculate the impedance of the voltage source, where Z is equal to 4 minus J2 plus 8 plus J10 whole multiplied by minus J2 whole divided by 8 plus J8, which on calculating will be getting 6.01 angle of minus 45 degree ohms. Now to find the current IA over here, we need to divide J20 divided by the impedance that is obtained over here. We need to apply this impedance over here, and the resulting value will be 3.328 angle of 135 degree ampere. On further calculation, we need to short the voltage source and retain the current source. The resulting network is as shown, that is I3, that is 5 amperes, and KVL on applying the KVL on I1 and I2. The resulting network will be shown is as shown in the slide here. Hmm. Here, on applying KVL on I1 and I2, we will be getting 8I1 plus I1 minus 5 multiplied by J10 plus I1 minus I2 multiplied by minus J2, which will be 0. Now, I1 minus I2, sorry, I2 minus I1 whole multiplied by minus J2 plus I2 minus 5 whole multiplied by minus J2 plus 4I2 will give us 0. On simplifying, we'll get 8 plus J8 of I1 plus J2 I2 will be equal to J50. And then we'll be getting J2 I1 plus 4 minus J4 into I2 will be minus J10. On solving this, we'll be getting a matrix form, that is IB or I2 will be equal to 2.897 angle of minus 23.96 degree of amperes. That is, IA will be 2.897 angle of minus 23.96 degree ampere. Since we have I1 and I2 in the opposite direction, we'll be getting IA minus IB, that is 6.11 to 1 into angle of 144.78 degree ampere. The second question is, the Wheatstone bridge in the circuit shown in figure is balanced when R2 will be equal to 1200 ohms. If the galvanometer has a resistance of 30 ohms, how much current will be detected by it when the bridge is unbalanced by setting R2 to 1204 ohms? Now, the diagram we have, or in circuit we have 120 volts R1 will be 900 ohms, R2 will be 1200 ohms, R3 will be 600 ohms, and R4 we have is 800 ohms. We have the galvanometer between point A and point B. To find the solution, first we need to find out the OC, voltage across O and C. Since we are interested in galvanometer current, hence it is removed from the current O to find VOC, and we get the circuit which is in the next slide. So before that we need to initially take down I1 and I2 values, where I1 will be 120 divided by 900 plus 600, that will be equal to 120 divided by 1500 amperes, and I2 will be 120 divided by 1204 plus 800, which will be equal to 120 divided by 2004 amperes. Looking at the circuit, we'll understand that A and B circuit is being open, that is applying KVL clockwise along the path of 1204 ohms, and that is B minus A across in this direction. We get 1204 I2 minus Vt minus 900 I1, which will be equal to 0. Vt will be equal to 1204 I2 minus 900 I1, which on multiplying will be getting 1204 into 120 divided by 2004 minus 90 into 120 divided by 1500, which will be equal to 95.8 millivolts. To find the RT, deactivating all the independent sources and look into the terminal A minus B to determine the Thevenin's resistance. That is, we'll be taking 900 ohms and 600 ohms here, which is in series. We'll be considering it as parallel, and 1204 and 800 ohms in the B part. This will be in series. With this will be in parallel over here. RT will be equal to RAB, that is equal to 600 parallel to 900 ohms and 800 parallel to 1204 ohms. Now we will be getting the value as 900 into 600 divided by 1500, 1204 into 800 divided by 2004, which on calculating will be getting 840.64 ohms. Hence the Thevenin's equivalent circuit consisting of 95.8 millivolts source is in series with 840.64 ohm resistors. If we connect 30 ohm resistor galvanometer resistance to this equivalent network, we'll be obtaining the circuit over here. That is 840.64 ohms resistance across A and 30 ohms resistance with current IG, which will be towards B, and 95.8 millivolts of galvanometer. The IG over here, the current IG over here will be given as 95.8 into 10 raised to minus 3 divided by 840.64 plus 30 ohms, which will be equal to 110.3 mu amperes. So I hope you have understood the problems regarding Thevenin's resistance and also about the superposition theorem. Thank you all for watching the video. Thank you.